Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, Best Practices for Building and Operating Data Lake on AWS. And presenting today's topic is Terumi. Terumi is an Amazon AAI training consultant and author holding more than 25 years of experience in IT. Her passion for cloud computing developed at a very early age. Being a teenager, she always showed her enthusiasm for understanding the technologies that make computers tick. This deep sense of curiosity on technology led her to achieve all the associate, professional, and specialty certifications and was recognized as an AWS Authorized Instructor Champion. Now, please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Data and AI practice area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. Today's session will cover learning about building and operating a data lake on AWS. This webinar covers key strategies and techniques that can help you unlock the power of your data and get the maximum value from your AWS data lake deployment. And now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handout section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Terumi, thank you so much for joining us today.
Hello, everyone, and welcome to the AWS webinar. Today's theme is Best Practice for Building and Operating Data Lake on AWS. My name is Terumi Laskowski, and I am your AWS Authorized Instructor. And this webinar will be around 30 to 40 minutes long, so it's not going to be that long, but we have a lot of content to cover, so let's go ahead and get started. Today's agenda looks like this. So we have 6 things. Overview of AWS services for Data Lake. So we'll talk about what is Data Lake. Second, we'll look at some of the common architectural considerations and introduce to you some component services on AWS. Third, how do you ingest data into Data Lake? That is, how do you bring in data? And then how do you integrate them with the rest of the system? So once again, here we will also be talking and introducing some common services on AWS to do that. Fourth, how do you implement security and data governance? 5, how do data lakes help to use data analytics and machine learning? Okay. That is, how do these services leverage data lakes? And then 6, how to optimize performance and how to optimize cost. And then I will have some time for answering some of your questions as a Q&A session. All right, so let's get started. The very first one that we'll talk about is overview of AWS services for Data Lake. Well, before we get started, let's go ahead and talk about what in the world is a data lake, right? Okay, so what is data lake? Well, basically, when you look at corporations and their data, right? They probably have databases, they probably have images, email, right? So these are non-database type of data. And, there are all types of data. Now, some survey have reviewed that up to about 10% of the corporate data these days are actually structured data. So that is things that have a clear format, standardized way that the data is stored, such as in the database. But that's only like 10%. So what are the rest of the 90% of the data? Well, they are usually not as structured or not even structured at all. Like take, for example, something like an image. That's not structured, right? So you can't really compare that to as an equivalent to a database. So that's the kind of data that we're talking about. So data lake is where you could put all that data all in one place. That's right. Not in disparate solutions such as in databases and some other storage and file sharing and all that. No, put it in all in one place. That's basically what a data lake is. But the thing is, why do we need to do that? Right? Because we have lived for a while without even having data lakes. So why now? Why do we need, data lakes? Well, if you imagine, what does data do for a corporation? Right? I mean, there are the various types of data, but the data is basically there to assist the company and corporations in improving their performance as far as the business is concerned, increase satisfaction of the customers and users and such. So you need to be able to leverage all the data for that purpose, not just some part of the data. So if you have the data in one place, it's much easier to use the data and look at it holistically, not just doing some data analysis on just a database and then doing some other type of analysis on other types of data and then trying to bring them back together, right? It's just easier if you have data in one place. Right? So that leads to these 3 things, right? Better decision making, hopefully, and faster decision making. And then you get insight into, if you're looking at customer data, what is the insight into the customer understanding and behaviors. And then hopefully, as a business as a whole, that you get intelligence on how the business is doing and how you can improve the process. Okay. There you go. So the solution that AWS provides, and there is a AWS Data Lake solution, have these components. Okay. Basically, the data lake must be able to identify where the external data are located. So these are data sources. And then you have to be able to bring that all into one place. So that's called data ingestion. And if you've dealt with data for a while, you see that sometimes data comes in like a totally wrong format, or sometimes the data is missing, or data there's like mistype and just erroneous information. I mean, the data comes in, but you just can't use the data as is most of the time. So that means One has to have the functionality to actually clean the data, perhaps even to transform the data, modify the data, and perhaps even to load it up in someplace else, right? So that's actually called ETL, right? Extract, transform, and load. So the data lake solution has to have that as well. And also, how do you get the insight? Well, you get the insight by querying it. So what are the querying features? Well, there's actually a service called Athena. Athena is a very lightweight way for you to use SQL, standard query language, into data that's inside S3, yeah, object storage for AWS, without taking the S3 data and putting it into a database. So Athena has the power to just query the files in S3 as if they were something like a relational database, I think, which is like a pretty wild idea. Amazon Redshift. Amazon Redshift is a data warehousing solution. So we're talking about like humongous amounts of data, but Redshift is basically a big SQL relate type database, right? So that's what data warehouse is. So that's basically structured data. But there is a extension of the Redshift called Redshift Spectrum, and Redshift Spectrum is actually able to query into S3. That is storage, that is the main storage component for data lakes, right? So there you go. So, but that's for data warehousing integration. And then there are other types of services, and there's a lot more services than I could list here. But as an extended functionality, Kinesis is often used to ingest and process real-time streaming data coming into data lakes, as well as Amazon SageMaker, which is a flagship product for the machine learning services given by AWS. So anyway, so these are some of the data lake solutions and its components. And we'll be talking most of these things in a little bit more detail in a later slide. All right, so now let's move on to the next section. So then let's consider then, how about the design and the architectural things that we need to think about when we're creating this data lake? Well, let's take a look. So we're now going to talk about data lake design principles. Okay. And so why is that important? Okay. So what happens is that if the data lake is where all the data resides, okay, that means you're getting data from all kinds of sources, right? Mixed bag of things all inside this data lake. Now, if we're not careful about what did we put in here? What kind of format is it? Did we clean it? Right. So if we're not mindful of those things, you could actually end up not really with data lake, but probably like data swamp, as I have here. Right. So it's pretty important to have certain things in mind as a design principle, so that the data lake doesn't really turn out to be a data swamp where you just have like a bunch of messy data. Like unorganized data inside this data lake. So let's take a look at the 3 design principles that I have selected for you. So one is a scalable architecture. Scalable architecture means that you can adjust the size, let's say, of storage or compute power depending upon the load that you have to handle. And the reason why is, they're multifold. One, remember, all this is in AWS. So AWS as a cloud service, you only have to pay for what you use. So you always want to have enough resources for what you need, but no more, no less, right? So that means if you need more, your underlying infrastructure, which is the data lake, needs to be able to expand. Or if you have fewer data, it needs to be able to shrink, right? So that's basically what a scalable architecture is, right? Depending upon some key metric that you would choose. Right. So the next one, so that's the design principle, right? To kind of think about, make sure that you have that feature. Next one is called data cataloging. So data cataloging, what is it, right? So it's a process of creating a comprehensive inventory or maybe directories of data that you have in an organization, right? So it involves organizing data, perhaps tagging the data, perhaps even classifying data, right? All in the effort to make it easy for someone to search and access that data. So data cataloging is a pretty important principle to kind of give you good understanding and organization of the data that's in there, right? Okay. And last but not least, security and compliance. Yes, where there is data, right? I'm sure there could be some privacy data, there could be some company intellectual data, some data that must be handled securely to abide by certain compliance requirement. So yeah, data lakes, because it's going to handle a lot of data, must be able to do security and compliance well. Okay, so these are the data lake design principles. All right, so in order to do these things, let's take a look then the key components of the data lake. Okay, so first, remember the way I describe data lake is that it's a place where you could put all your data in one place. Okay, so that means it's mainly about storage. Okay, I mean that's a major component. Right? It's not the only component, but it's a major component. Right? So it's about having a centralized data storage. Okay. So in case of AWS, to have the centralized data storage where it really doesn't care what kind of data you put in, S3 is the perfect choice, right? Because S3 is object storage, which basically handles all the data and looks at the data and say, oh, it's a blob. Yeah, BLOB. Okay. So what's a blob? Binary large object, right? So that's saying that the S3 basically sees everything that you put inside it as just a bunch of ones and zeros. Okay, that's pretty handy because we want something that doesn't really care as to what kind of data you have in there. Okay. Now, there's something called Amazon S3 Glacier. Right? S3 Glacier is more of an archival storage. So it's very similar to S3 in that you can put anything in there, but the storage costs tend to be very, very low. But retrieval time usually is longer. So you do have to be careful as to how quick of a response time you need to have to retrieve the data. Right? So if you need to have a snap, access to your data, then Glacier most likely is not going to be the answer. But AWS has been adding different types of Glacier where you have different data recovery times, right? So you may be able to use some of the Glacier for your for your needs, even though you need to have it fairly fast, right? But if you're not careful, there will be some Glacier services. If you don't choose correctly, it will take up to like 12 hours to retrieve your data. So, but it's there for you. It's an option, right? For data ingestion, transformation, integration with the rest of the system, there are a couple of services that I want to highlight here. One is called AWS Glue. AWS Glue is primarily AWS's ETL solution. Extract, transform, and load. Okay, and you're able to script it. It can do complex transformation, so it's a very, very nice tool. The other one is called AWS Lake Formation Workflows. So with the workflows, what you can do is it'll automate and orchestrate. So that's like organizing and moving things forward in loading data and transforming processes. And AWS Lake Formation Workflow works with Glue as well. Next one is security and access control. Okay. Now in AWS, primarily when we talk about access control, we are referring to the IAM services, right? Identity and access management. This is where you create your users, temporary users such as roles, create permissions using policy, and assigning policy to these identities such as users and roles and groups. Okay. But with Data Lake, AWS actually has another type of access control, which is more granular, that is geared specifically towards data lake. And this is called AWS Lake Formation Access Control. So you actually are able to use combination of two things, the IAM and also lake formation access control. And I do have a slide that kind of gives you a little bit more information about this thing called the lake formation. Okay. Next one is analytics and processing. So if your analytics, that is, you're analyzing data as part of a data warehousing solution, then you could use Amazon Redshift Spectrum to integrate right into S3, which is going to be the storage for data lake. Or if you have massive amounts of data, and it's very likely that you will have in your data lake massive amounts of data, if you want to do what is typically called the big data processing, then the solution for that is the EMR, which stands for Elastic MapReduce. Okay? And it's an implementation of Apache Hadoop. Right? So this is where you take lots of data and you distribute it across multiple compute nodes, and you do work in parallel to just process a lot of data in a short amount of time. Then at the end, you aggregate the results from all those different processes, and then you get one result. So that's basically EMR. And data lakes and EMR is integrated very nicely. And then, of course, real-time data processing and streaming. I did mention something about Amazon Kinesis. Okay, so there you go. So these are some of the components of the data lake, and there are others too, but these are the core components. All right then. So what would be the best practice in data lake architecture from this perspective? Okay, and I have highlighted 3 items here. So one is called decoupling storage and compute. Okay, so the difference between these types of services is that storage obviously stores data, right? But compute is the type of service that will crunch the data, right? That will actually run in like a program, bring it in memory and just crunch that data or to work with that data, right? So there's obviously a difference in purpose, right? So you have something that's using the CPU, using the random access memory and all that, and then the other one is storing, right? And there are different types of storage, of course, but those are the differences. So decoupling means to separate out the two, and you have compute separately, that is independently from storage, right? It's nice to have it that way, mainly because if you have it the other way around, that is, you have something that where the compute and storage is tightly coupled together, that is, they are just like one piece, right? Okay, then what if you have a need for increased processing power? Well, if they're tightly combined together, it's very hard to just increase the capacity of your compute. You probably have to increase the entire thing, which we may have to increase the storage as well, right? It might. How about the other way around? The data crunching requirement doesn't really matter, but the storage has to increase. Well, normally if if it's one piece, if you increase the storage, chances are everything else is going to come with it. So there's going to be some waste, either being compute or storage. But if you separate them together, separate out, so you have the compute individually, independently scaling, regardless of what the storage is doing, and storage increasing and expanding separately or shrinking separately, regardless of what the compute is doing. Now, the whole system can scale depending upon the exact need, let's say, i.e., of the processors or the compute and storage. They can scale separately, which will which probably make it faster, right, to scale, as well as reduce the waste, right? Because you are scaling exactly in places that what you need to scale and not in the others. Anyway, so that's decoupling storage and compute. Okay. Now, automated data management. Okay, so it's really important in the cloud, especially, to automate tasks And data management is no exception. Okay. Now there are tools that will help you to automate all kinds of things. Okay. Well, firstly, that glue, that's automated, right? So the ETL can be automated, right? You can schedule them, on like daily basis. You can schedule them, or so that when something triggers something, glue can actually work and do the ETL work, right? So only when it's needed. Okay? Or you can have something called AWS Data Pipeline. So data pipeline is able to receive data from specific sources and then process and push that data forward to the second processing, activities, whatever that is, right? So it's able to move data forward um, automatically, right? So once you construct this data pipeline. So those are some of the automated data management side. Then last but not least, monitoring and optimization. That's always important, whether it's being data lakes or not data lakes, right? Uh, Mainly because, um, you know, only through monitoring, you will find out if your assumptions are correct. Maybe you have to tweak your assumptions about what is your need, how big things have to be, how fast things have to be, right? So tools such as AWS CloudWatch will help you. So CloudWatch, there is something called CloudWatch events, which you can specifically look for certain things to happen. And when certain things happen, you could take some actions, such as notifying someone or triggering other activities. And CloudWatch also has something called metric, so that you can look at the metric, and based on certain metric like CPU utilization or storage utilization, that you could set up alarms. And the alarms work very similar to capturing these events, in that when certain conditions happen that you're looking for, let's say some 90% utilization on CPU or something, then you can perform certain actions based on that, trigger certain actions such as notification, um, you know, or perhaps even automatically try to scale, right, so that you can alleviate these kinds of conditions. Okay, and then that will lead to optimization, because now you have a better understanding of what's happening with your system, as well as automating responses when certain things happen. There you go. So that would be the best practices. Okay. All right, so moving forward, let's go and talk about the next one here. Now moving on to the next topic. Okay. So data ingestion and integration. All right, so that is reading in the data and then making it so that everybody can access the data in the same, similar fashion. Okay. So here we go. So how do you ingest data? Right? How does one ingest data in AWS? Well, it's pretty critical, right? You have to be able to bring in the data, okay? And you're going to have all kinds of different sources. So there are three ways, well, actually two ways, two things that I want to talk about here. One is that you can bring in data in batch, or you can bring in data in real time, right? So batch ingestion is about collecting data and importing data at a scheduled interval, once a day, twice a day, what have you, right? You can do that. Or in real time, right? So that means it's continuous streaming and processing of data as it's generated, right? And you usually do that for things that are pretty time sensitive, or time sensitive data application that needs that kind of a response. So those are two different ingestions. Now, remember, data lake handles all kinds of data that the corporation uses. Okay, that means data source is going to come all over the place. Data types, data format, the way things look and feel, it's going to be so different. So that means it's a source diversity, right? There's going to be various sources, but what you want to do is that you want to be able to ingest all those data, right? They may come from IoT devices, they may come from databases, they may come from on-premises data sources, right? But you have to be able to ingest all that data. And then, it's called unified ingestion. So it streamlines the ingestion of different data formats and structures into the data lake. Okay. So just a little bit more about the data source diversity. Okay, AWS Data Lake can ingest data from diverse sources. That's goes without saying. Okay, because that's what it's for. So, but there are challenges, right? Because there are challenges because of data types and formats are different, and there are AWS services that will help you to normalize that data. That is to sort of kind of make it look the same. Okay, yeah. So we'll have some discussions on that too. Okay, so let's take a look at some of the common tools for doing this. One is Kinesis. I've already mentioned it. Kinesis is a real-time streaming, and there is a component of Kinesis that you can actually do real-time analytics on it as well. Okay, so you can, and what's nice about Kinesis is that you can handle high volume of data simultaneously from multiple sources, right? Which is very, very nice. Now, there's another one that I briefly mentioned earlier, which is called data pipeline. So data pipeline is mostly an orchestration service of data workflows, right? So it automates the data movement from ingestion, right, from diverse sources into the data lake, and perhaps beyond. Okay. All right, so there you go. So that's the method of data ingestion. The next one here is data integration. Okay. So data integration is really central to the efficient data lake strategy because it involves what's called harmonizing data from various sources. Harmonizing is to make it work together, right? Make it look the same, make it act the same, right? That way. Okay? So making it by doing that, you make it more accessible and useful, right, for analytics, and make sure that there is some consistency and data quality uh, assurance for that. Okay, as you go through this step. So anyway, so I have here that is the data integration is that you can definitely do data unification using Glue, right? Because Glue will be able to ingest data from various sources as well as transform the data, okay, and then go ahead and load that data up someplace else. So in the transformation is where the secret sauce is. That is, you can do all types of transformation using Glue automatically. Okay? That will help you to unify the data. So there it is, right? Structured, unstructured data, it really doesn't matter. You can use it to cleanse the data, get rid of the stuff that's kind of, doesn't make sense, it's a mistake, it's missing, or, fill in the blanks, right? So think of all kinds of transformation. If you've ever done, machine learning, data cleansing part is like really, really, it's a bear of a task. It's a lot of, it takes a lot of time, and Glue really comes in handy in that respect too. Data consistency. Okay, so data consistency means how does the data quality is assured, and governance, that is the requirement for data. Okay, how are they actually implemented, right? So there is a feature of that in the AWS Lake Formation. By the way, I think in a couple more slides, I do have an explanation of what this lake formation is all about. Right? So kind of, I'm not going to go too much into detail. Just understand that lake formation actually has a way for you to assure quality and also to assure data governance or to control data governance. Okay. All right. So what are some challenges then? In data integration. Okay, so some of these are data quality issues, right? So as in machine learning, as in anything, the data that comes in, right, isn't always fit for consumption. Okay, so you need to be able to control quality there and to handle that situation. Now, more and more, there's actually more data, and there are more data that's not structured coming into corporations, and because of that, that is going to actually affect the data transformation complexity, right? So the complexity, you're going to have something that can actually handle this complexity, right? Of how data is formatted and how they're related. And Glue actually is very good for this too. Now, the last part here is integrating with existing systems. Now, some of you may want to call that legacy systems Well, that's usually a big requirement too, right, for corporations. Now, AWS actually has a lot of solution for you to combine or integrate or migrate your legacy solutions slash data into AWS. Okay. Now, some of these are, if you have your data on premises on databases, there's a database connectors, okay, connector applications and services. You can actually connect your data center directly to AWS. So there'll be like a direct ingestion from your data center called Direct Connect, okay, without going through the internet. AWS actually has a pretty full set of the API integration using SDKs. I believe there's like 6 or 7 programming languages and SDKs that are supported. Okay. There are also a healthy number of third-party solutions. You may want to take a look at the AWS Marketplace for that. Okay. And then, of course, you could create custom scripts, right? If there isn't anything else, because you know your legacy systems or on-premises system well. So then, write some kind of script and then import the data into AWS. So there you go. You could also do batch data transfer too. Right? Anyway, so those are the integration with existing systems. Anyway, so let's take a moment and take a look at this thing called the AWS Lake Formation that I've kind of mentioned like a couple times. Okay. So what is it? Well, Lake Formation is you could say, comprehensive data lake management service provided by AWS. Right. So what does it do? Well, it does all those things. All those bullet points. Okay. So if you actually want to create data lake, actually they have blueprints and make it simple for you to create data lake itself. Okay. And when I say data lake, I'm talking about storage as well as some typical data sources that you're going to be ingesting data from. Okay. So those are something that's already, templated, okay, so to speak. Data ingestion provides tools for ingesting data from various sources, okay, including databases and such. Data catalog, right? Remember, data catalog is a way for you to organize the data, take the inventory, and make sure you know what kind of format you have. So that's the data catalog. So Lake Formation actually includes a built-in data catalog that centralizes metadata management. So data catalogs and metadata describes the data, right? So you understand what type of data is in data lake. So that's there too. Data security, of course, right? And data transformation. Yes, right? You can already tell that we've already talked about Glue, so that feature is there. Integrating with the analytics services, right? So we're talking about integration with Redshift, perhaps SageMaker, and other types of analytical solutions. Data governance, right? Remember I told you that the Lake Formation actually has data governance. So it does allow your organization to implement data governance policies and maintain certain data quality standards. Okay. So that's there as well. It's scalable, right? And you can manage cost. And we'll talk about cost efficiency a little bit later on. But all these features are actually built in as one service called Lake Formation. Okay. All right. So let's take a look at implementing security and data governance, right? That we've briefly covered. So security is about protecting your IT resources, and data lake is going to have a bunch of IT resources, which is data, right? Okay. So these are typical ways that one will protect data. Data encryption, there you go. It protects the confidentiality of your data. So encryption at rest, that is in storage, and encryption transit, that is when the data is moving. And that's usually accomplished by using TLS, transport layer security, right? You're probably used to using that. Access control, right? Yeah, controlling access is one of the more important security measures that you can take. Now, as I've already mentioned, that in data lake, using lake formation as a combination to data lake, is that you can use both the IAM, identity and access management, which is normally how you control access to your AWS resources, and very specialized purpose-built access control just for lake formation / data lake. It's called lake formation access control. And it's a fine-grained access control just for your data lake features. So that means in data lake using lake formation, you will use IAM as well as lake formation access control. So you have, one that is more generic for the underlying infrastructure, and another one that's more specific to that application, which is accessing the data, and the data governance, right, and compliance needs you may have, and to have that much more finer grained access to that data. Okay, so there are two different types, right? And then compliance and standards. Well, it's going to help you, right, to by doing security, it's going to help you to comply with certain standards like HIPAA, right, for healthcare information, GDPR for privacy information, for privacy policies and protections for EU, citizens, right? And there you go. So these are basically the security features, but these are not just data lake security features. Other than the lake formation access control, all these other things are in general what's available in AWS to protect your data in general. Now let's go into data governance. Right. So data governance is about making sure that what your company has stated that what you're going to do with the data, right, and how you're going to use this data and how you're going to protect the data is actually being done, right? And a lot of times by compliance, you have to show evidence that yes, you are doing what you said that you're going to do. Okay, so that's usually what governance is. So data governance then has three components here. One is data cataloging and metadata, the other one is data lineage and tracking, and the other one is data quality and lifecycle. So let me briefly cover each of these. So data catalog and metadata. So we've already talked about data catalog, right? So we use Glue data catalog normally for categorizing our data and managing the metadata, right? So you may ask, well, why is metadata important? Like, what's that, right? Well, it actually allows us to understand the data context, the lineage, like where it came from, okay, and finding it, discovery, right? That's what metadata is really important. That's why it also has to be available and also accurate, right? So it means that we can easily find and hopefully trust and use that data for maybe analytics, right? And it's really vital for regulatory compliance as well, because they require that you understand what you have, right? You have to prove what data you have, and and all the other context that's related to it. Next one is data lineage and tracking. So when we say lineage and tracking, we're really emphasizing the importance of tracing the data from where did it come from its source, to where did it go, to destination. Okay, so AWS actually provides with some tools in the lake formation for tracking data lineage. Okay, so why is that really important, right? Well, because it supports accountability, right? It leaves audit trails, right? And for compliance, usually auditors going to ask for that data. Okay, so in the data lake, tracking data lineage allows you data quality. You know where it's coming from, right? Okay, so that's allows you for data quality, and you see the origin transparently. And it says, oh, where did it come from? Well, it came from there. Okay, and it really does help to identify and fix any kind of issues in data and data workflow. Okay. Last but not least, data quality and lifecycle. Okay, so what we're talking about here is that what are the strategies for maintaining data quality and consistency, right? Well, S3 comes into play with data quality rules and lifecycle management. Right? We'll touch a little bit about that a little bit later on. But S3 actually allows you to keep something called the retention policy, okay, and archiving, and what's called lifecycle rules, where you move data from one location to another for cost purposes, for retrieval optimization. Okay. So that you can always kind of see the data movement, and that is going to help you to kind of ensure that you understand what data you're looking for and where it came from, so that data will remain accurate as it's being moved, because S3 is going to move the data for you. Okay, and that is reliable because S3 actually does have a very high reliability when it comes to availability and durability. Okay, and hopefully compliant about the data governance over time. Anyway, so proper data lifecycle management does also optimize storage costs, but we'll talk about that in the costing section. Okay. So what's the best practice for security and governance? Well, it's not, once again, it's not just about data, data lake. It's in general regular security audits, right? This is very much like monitoring. You could come up with all beautiful policies and procedures, but if you're not following them, right, it doesn't mean much. So auditing will kind of keep you honest. Okay? And it does document and show to the world that yes, you are doing what you said you're doing. Automated compliance monitoring, we did talk about automation, so that's pretty important. And not if not only for the fact that data and systems in general and cloud changes very quickly. So you want to be able to keep track with all these dynamic changes. And about the only way you're going to do that is to automate all the rest of the process, okay, including monitoring. And last but not least, user education and training, right? The hallmark of cloud is that it's self-serve, right? It's self-service on demand. Okay? But if you don't know what you're doing, right, that feature is not going to be too handy for you. So, one has to learn what can you do, what must you not do, especially with data lake, like what are the features and what are what are some concerns that you have to kind of keep track. And also, of course, if you don't do user education training, they won't understand the importance of making sure that because things do change, that you have to keep monitoring it and optimize it, right? So anyway, so everybody understanding, better the cloud, it's better for everyone, right? All right then, so let's talk about the exploring data analytics in ML. So this is usage of the services in conjunction with data lake. So let's kind of take a look and see, what is analytics and ML in AWS, right? Well, basically, analytics is the way that you gain insight, not just about doing simple queries and stuff. No, right? You're not trying to locate something. You're trying to get some intelligence from massive amounts of data that you have. And now with Data Lake, you have the advantage of being able to aggregate data from all different sources to try to get better insight as to what's happening, right, in your company, okay? And also with your customers. So Redshift, Athena. Now, we've already talked about. QuickSight, we haven't talked about, right? So we will have an opportunity to talk about that a little bit later. Machine learning, same thing. Machine learning, you are using artificial intelligence, right, to kind of supercharge your analytics with artificial intelligence. Okay, so that's basically what the SageMaker does. Okay. And also deep learning AMIs, so Amazon Machine Images, are specially built images to spin up your virtual machines that are already equipped for you to run deep learning type of stuff. Okay, so it's pre-configured. Okay. Deep Lens, it's an example of certain things that AWS has been producing. Deep Lens specifically is a piece of hardware with camera that you can download your machine learning trained models into so that you can have it in the home. Deep Lens, because it's integrated with a camera and it has intelligence, it's able to recognize, right, objects like, like dog or cat walking by. I'll say, oh, that's a dog, right? Not only is it a dog, oh, it's a, Fido, my dog, right? Anyway, so that's the kind of stuff. So Deep Lens is that. And, AWS has other hardware that you could do something similar with. Okay. So the question then is, well, how do you combine that with Data Lake? Because you don't have to combine these with Data Lake. You could do analytics and you could do, ML without Data Lake. But we're talking about Data Lake today. So how does that work with Data Lake? Okay. So quickly, we'll talk about the AWS Analytics service with Data Lake. Okay. Now, Redshift, as I mentioned earlier, is a data warehousing solution. Right? It's a humongous data warehousing solution, but it's basically SQL-based, structured query language-based. Right? So it's designed for very complex ad hoc queries at a at a high performance. Okay, so you can integrate data lakes with the Redshift. As I mentioned earlier, Redshift Spectrum is able to reach right into S3, okay, which is the storage component of data lake, and do queries. And the Spectrum interfaces with Redshift. So that means eventually what you're doing is data lake is providing you the the query results using data warehousing. So if you want to integrate data lake with data warehousing, this is the route to go to. Athena, now it's not a warehousing solution, but it is a serverless, so you don't have to worry about servers and stuff. And you could do SQL query right into S3 objects. Okay, so um, Athena uses something called, you applying schema on read. So as the data is written, there's no schema that is structure, right? That Athena needs to know. But when it reads it, it has to apply the schema. But that is very, very flexible, right? And very agile. Okay. So Athena works like that. And QuickSight, right? So this is a service that I haven't talked about. So QuickSight allows users, especially like end users, to actually create interactively data visualization, um, you know, uh, drill down into certain queries. They can construct queries on their own. If of course they need training, but they can construct it so that you don't have to have an IT person to intermediate what the business people want to actually gain from that data, right? The data insight. So it's really, I think, freeing, right, both to the IT and also to the businesses, that they have access to this like enormous amounts of data that they can go ahead and query, right, and see, visualize it. So it's a real nice, visualization tool, and also a query tool. Anyway, so the source integration seamlessly connect with data lakes, databases, third-party data. So yeah, so QuickSight is able to integrate with different sources, including data lakes. All right, so moving on to the machine learning side of the house. Okay, now there are tons of machine learning services available with AWS, but right now I want to concentrate talking about SageMaker. Okay, because SageMaker is the flagship service that AWS offers that provides you with a complete machine learning solution, right? From development, from data preparation, model training, model testing, model deployment, model operation, right? Just think about anything you would need for machine learning and deploy that and have it run. Yeah, SageMaker, one way or another, will allow you to do that. Okay, so how does it integrate with data lake? Well, machine learning, if you've actually worked there before, it requires like tons and tons of data, right? Okay, all right. So data lake is where you have all that data. So you can go ahead and read data from data lake right into SageMaker. SageMaker actually, even without data lakes, is expects these training data to be in S3 anyway. So there is that integration there already. Okay, so it does seamlessly connect with data lake. The integration of machine learning with data lake is that yes, machine learning model can leverage the data lake to access all kinds of data, right? Structured data, non-structured data, yeah, so it works. And also, machine learning requires a lot of data cleansing, okay, and data transformation a lot. And data lakes actually has all those features built in, which makes it really, really nice. Okay, so what we're looking for in the end, though, right, is to get you to enhance your analytics, right? And and predictions from that analytics with the powerful backing of ML, right? ML driven insight. Very, very powerful stuff. Anyway, so let's go and talk about the last section, which is how to optimize performance and cost efficiency, right? Okay. So, after all these things are nice, and you may be saying, my gosh, how much is it going to cost? Right? Okay, so here we are. So let's talk about performance. Okay. So performance then is how can you enhance performance, right? Faster, better, right? All that. Okay. Because you want to be able to efficiently do all these things. Okay. of analytics and machine learning and all that, right? So some of these key strategies are, right, data storage, okay? Because with S3, there are classes, right? Like standard class, all the way to glacier class, right? And because of all the different classes, they're all about, how much does it cost to store, but that's on the costing side. But how long does it take to retrieve the data, right? So that's a performance size. So there's usually a trade-off between increased performance with higher costs, right? Okay, so you do have to kind of take a look and see what do you need exactly, and find the proper class in S3 that will do that for you. Okay. Now, data processing optimization, sure, right? When you're doing the data processing, what you want to do is you don't want to over expand on compute capabilities. So you want to make sure that anything that processes the data, that you have selected just the right size, right? So that you're not paying more for unused capacity. Okay. So glue, EMR, okay, all these things, you can choose the type of compute resources that you'll be using, okay, for optimization. Indexing and cataloging, right? So this is the last topic that we'll talk about here, is that the Glue data catalog actually provides a unified view into the assets, including the catalog, okay, and usually the Redshift Spectrum and Athena is going to be using these catalogs. Okay, so it allows you then to query diverse formats, without pre-processing, which will enhance the optimization. Okay, there you go. Oh, that is enhance the performance. I'm sorry. Okay, so there you have it. Next one though, let's talk about cost. How can we not, so like I said, normally when you try to enhance performance, you usually incur more cost, right? But when you reduce the cost, you usually pay for it in performance. So you may want to kind of make a decision as to, all right, so which one's important, performance or cost, right? Usually, I mean, I'm not saying all the time, but most of the time, that's that trade-off. Okay, so on the cost optimization, storage costs, right? Once again, if you go cheaper on the S3, on storage, your performance in retrieval becomes worse. Okay, so it gets slower, right? And so that is the trade-off usually. And also, if you were to compress the data, obviously it's going to take shorter time to handle. So you may want to do that. And the data, the brand new data that goes into data lake may be accessed often because it's new. But as the data ages, maybe it doesn't, right? So that is fewer people are accessing it for any kind of a business intelligence work. Then you may want to move that data as it gets older and less people are accessing it to a cheaper classes, so that you can optimize depending upon the level of usage per data type. You can do that in S3. Okay. Resource scaling. So scaling means normally you're talking about scaling of compute resources. That is the data crunching part. And what does data crunching in AWS? Well, I have some information here. Maybe Lambda. With Lambda is a serverless compute platform. You could use it for any kind of running programs. Okay, and you could select how much memory you need. Yeah, how much parallel lambdas you're going to allow. So these are cost optimization strategies. EMR clusters, how many servers in a cluster, how big are the servers. Okay, spot instances. Spot instances, in case of, let's say, EMR, is great for worker nodes, but not good at all for control node, like the brain part of it, because spot instances are the cheapest way, the way you're going to use your EC2 instances on anything that requires the EC2. But AWS can take it away at any time, right? Okay, because it's all driven by the the supply and demand, right? So if there is few demand and there are a lot of supply, it's cheaper. But as the demand increases, fewer supply, it gets more expensive. Okay, so anyway, that's basically what a spot instance is referring to. Okay, now monitoring and cost visibility. You may want to keep track of these costs using certain monitoring features. When it comes to cost, AWS Cost Explorer probably is the best way to do it. Okay, and if you see that the cost is going up, and it's off your expectation, you may want to find out why. Right, you could drill down and find out exactly what's costing you more. CloudWatch alarms can trigger an alarm when you go over certain budgets on certain resources. So it'll give you, a warning when something's going over. Okay, and then regular architecture review should do it, right? And it says, okay, are the needs that we thought we needed, is it still meeting its requirement? Is it over provisioning or is it under provisioning? Right. So there you go. That's basically how you would do cost optimization. And definitely AWS has like a bunch of data and tools that will give you, insight into that as well. Okay, so that's it. So we talked about in the past a little bit over 30 minutes, sorry, overview of the services. What is it, right, of the data lake? What are the architectural considerations? And we talked about S3, Glacier, and such, right? And data ingestion integration. So we talked about glue being ingestion as well as transformation. Kinesis, real-time streaming information, ingesting that. We talked about implementing security and data governance. There are a lot of things that's in general, but there are certain things that are specific, especially the access control mechanisms. And exploring data analytics in ML, like what can you do? What are some of the services? And why are we talking about it with data lake? And then lastly, we talked about the optimizing performance and cost efficiency. Okay, so I hope you learned something new that you can use to start using data lakes. And I will now wait for your questions. Thank you.
Thank you, Terumi. That was very informative. I know everyone is looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And now I'd like to give the presentation rights over to Rimi, our vendor manager, to introduce our promotions and webinar-related courses.
Thank you so much. And once again, a very warm welcome to everyone who has joined our today's session. Now, I would like to take you all through some of our handpicked resources, which we think will immensely help in accelerating your learning journey on AWS. Starting off with a quick overview of Netcom Learning and what sets us apart from the other cloud training leaders. We have very recently been recognized by trainingindustry.com as one of the top 20 IT training companies in the US. Another major driver of our expertise is our 25 plus years of industry presence. We have been able to service over these last 25 years to over 80% of the Fortune 500 companies in both the B2B as well as the B2G space. Now, we just wanted to mention that this session is being recorded. So in case you want to refer back to any of the topics that will be covered during the today's session, we will be sharing the recording with you later on, so you can access the recording through that link. Moving to the recommended courses, which we think will best suit your learning journey. What you see right now are some of our upcoming training batches on the top courses, which you can register for. The dates have been mentioned, but in case you have any queries regarding the same, you can at any time reach out to our team. We also have a mix of the most relevant resources, which will help you get a better understanding on some of the other AWS courses. Moving on to the AWS skilling program. So this helps you to develop role-based cloud skills, working side by side our champion level AWS authorized instructors who train cloud professionals on the latest AWS technologies and tools. So now as a part of the program, you and your organization both may also be eligible for free AWS certification exam vouchers and extended lab facilities that extend up to 5 weeks after the completion of the training. Now we are excited to also bring to you the AWS Skill Builder, which is a new learning center with 600 plus free digital courses that is built by the AWS experts. This includes the game-based learning opportunities with CloudQuest and team-based competition with Gen. Its unique set of offerings actually include practical real-world and hands-on lab experiences in a live AWS environment. Now, this is something that we personally love because it showcases the effort that the AWS team takes to make the learning as fun and immersive for the learners. Moving on, another big announcement that we have for our learners today, and something that I had given a hint in the previous, in one of the previous slides, is about our ongoing discount fest, which, as a part of which, you can now choose the AWS training which suits your job role, and you can enroll yourself at almost half of the original price. Please note that this offer is applicable only on the course trainings and not on the course certifications, and the last date to enroll for this is September 30th. Moving on, our free AWS e-learning resources follow a self-paced training model wherein you get the liberty of accessing extensive course-related videos that are delivered by the AWS subject matter experts on the go. So these videos cover the availability on the device of your choice. So you can access them from your laptop, from your tablet, from your phones as well. So please feel free to access these free resources and make the most out of them. Additionally, please feel free to register for a demo to get an idea on what our 2-hour private group trainings on AWS entails. Now, these trainings will be delivered by our AWS authorized instructors with an agenda of understanding the different AWS services and solutions, and will be beneficial for you to devise a roadmap as per your team's current learning needs. The Amazon Web Services Learning Needs Analysis, which we also call as AWS LNA. Now, this is a free self-assessment tool that helps you identify your organization's cloud skills gap. That includes the participating employees to complete an adaptive e-survey that takes no more than 15 minutes, depending on the role. The idea here is to come up with a targeted, cost-effective training and certification plan that's right for your organization and addresses the specific needs of your employees. Moving on, we have the Learning Passport next, which is a flexible team training package specifically designed and customized for the number of learners you have. The Learning Passport is redeemable across our entire portfolio, which covers more than 4,000 official courses valid over 12 months. Now we have an exciting solution for you, which is Netcom Plus Learning Subscription that is there for our enterprise customers. So all you need to do here is to pay one time and you get unlimited access to authorized training from top vendors that includes AWS for a span of 12 months, which is 1 year. Currently, we have 3 packages available. You can get started for free with a silver pack, the one that you see on the first block, which allows you access to more than 300 learning modules. You can upgrade to the gold pack for just $199 and access 400 plus learning modules in addition to the silver pack benefits. And lastly, we highly recommend our most popular offering of all and ideal for our enterprise customers, which is the platinum package that can be unlocked if you have more than 10 learners. Now, in terms of the benefits, it gives you access to 400 plus learning modules and 100 plus virtual instructor-led courses across top vendors. So it's a great offering that Netcom team has curated just for our learners. So if you require the details, we will be sharing all the details with you, the links with you. Please take some time to go through them. And if you are interested, we have our team uh, that can answer any of your queries that you might have around the learner subscription. Now, in addition to our custom programs, do feel free to also go through some of our additional resources, which are curated, keeping the learners' needs in demand, and let us know learners' needs in mind, and let us know in the comments if you have any recommendations for us with respect to coming up with more such assets. Now, apart from our virtual sessions, you can also catch the relevant updates related to IT and business training through our social media handles. So please feel free to follow us on all for all the latest updates. Now, lastly, the CEO of Netcom Learning is an avid writer, and you can check out a glimpse of his book, which is a practical, actionable guide on how to boost performance, successfully manage change, and innovate more quickly. Thank you.
Thanks so much for guiding us through that information, Remy. And now we're going to go ahead and jump right into our question and answer session. If you haven't yet, it's not too late to pop your questions into the question panel. And as we start our Q&A sessions, we're also going to launch a quick poll that we want to invite you to participate in. Doing so helps us to know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register. First question we have is, can you explain the key differences between Amazon S3 and Amazon Redshift Spectrum when it comes to querying data in Data Lake?
Well, thank you very much for asking that. I don't know if I actually answered that in the presentation, so I'm so glad you asked. So the answer here is that S3 is basically a scalable object storage service. And I think I mentioned in my presentation that it's called the blob storage, right? Binary large object. Okay. So S3 is basically storage, right? But Amazon Redshift Spectrum is a query service, not storage, just query, right? That allows you to run SQL queries, standard query language queries, okay, on the data that is in S3, right? So Redshift Spectrum, right, is optimized for very complex analytical queries, and you can use it with Amazon Redshift for data warehousing. Right? So that's the key difference. S3 storage, Spectrum is query service.
Let's take another one. What are some common use cases for AWS Data Lake, and can you provide examples of industries or businesses benefiting from them?
Okay, so thank you for that because I don't think I actually covered that in my webinar. So the answer here is that AWS data lakes are very much used across all kinds of industries for purposes like data analytics, machine learning, data consolidation. right? So those are three key use cases. So some of the examples are, let's say, financial institutions, right? Financial institutions usually have a lot of transactional data. So if one wants to analyze the transaction data, okay, and by the way, machine learning is used for fraud detection, okay, for example. So that would be one example. Healthcare, right? Maybe managing, patient records, right? And behaviors and such, right? And another example would be, let's say, e-commerce. So e-commerce companies trying to analyze customer behavior, right? For marketing, for personalization. Yeah, I think those probably would be the common use cases.
Our last question for today's session is, what is the cost structure for AWS data lakes, and how can organizations optimize costs while managing large volumes of data?
So I believe I cover part of that in my webinar. So the AWS data lakes actually offer very flexible pricing options, right? But the cost itself can change based on how much data you're storing, right? And how much data are you processing, okay? And how about the analytics services? How about the querying, right? So because these costs, in most part will individually relate to the services that you're using, underlying services, right? So if it's S3, it's, how much data that's going out of S3, how much data that's in S3, right? So things like that, okay? Let's see. And in addition to that, when we're talking about costing, you could pretty much optimize costs by using storage is going to be a major part, right? So by using data lifecycle policies, so these lifecycle policies are where you can schedule or automate movement of your objects to different storage classes of S3, which will usually reduce the cost, but will increase the access fees, right? So when you move to lower storage cost options, you usually want to make sure that you're not going to be accessing the data as much, right? So that's usually the trade-off. And if you move into Glacier, not only are you not going to be accessing as much, but you're not really expecting, high speed access, right? Because the data probably won't be there that quickly. Okay. It does depend on which Glacier you choose, though. Okay. Let's see. Um, Also, when you're trying to scale resources based on workload demands, you want to make sure that you use, something similar to auto scaling, or automatic scaling of your compute resources, so you're not provisioning, or over provisioning your compute resources. Yeah, I think those are probably the main components of the cost. All right. Hey, thank you so much for those questions.
Once again, I want to remind you that as you leave this session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.